Alright, this is 4.3c. We're going to finish up in this video. Hopefully it won't take too long. So, recall that when we have this graph for any base A, I just put A on there as a letter, can be anything, it has the x-intercept at 1, 0. Okay? The domain is the set of positive real numbers, and the range is the set of all real numbers. The y-axis is the vertical asymptote. Okay, so it never crosses the y-axis. But when we have things that are general equation like that, but we make some changes to them, like in this, we did this earlier. So when we have ln, and instead of just having a base and a number or a letter, we add 3 to that x. There are some things that happen. What happens when you add a 3 to that is it shifts left or right. If this number is positive, it shifts to the left. If it were negative, it would shift to the right. Okay? And the domain is also changed because the domain on here are all numbers greater than -3. Okay, because this cannot be 0. So, -3 to infinity is my domain, or my possible x's. So therefore, -3 is my vertical asymptote. And that's why I said it. When this is positive, it shifts left because of what makes this 0, -3. So notice that it shifted 1, 2, 3 to the left. So even though this is a plus, and you're thinking plus is to the right, that's true. But it shifts to the left because of the domain. Okay, so then we get a graph then that shifts from here to shifting over 3, like that. Okay, so it shifted from crossing at 1 to crossing at -3. It went, or -2. It went 3 over. Okay. So for b, I have f of x, but that is 3 minus 1/2 ln of x. Okay, so we have ln of x. What do we do to it? We have a 1/2 in front of it, a minus sign, and then a 3 here that's separate from that. This is not 3 minus 1/2. You can't do that. This has to be done first, and then subtract it from your 3. So what happens? Alright, let's look at each piece here. This 1/2 means it shrinks vertically. Okay. This minus sign means it reflects across the x-axis. This means that with the number here, the number in front, it translates up 3 points. So the 1/2 means it shrinks. The negative means it reflects across the x-axis, and the number here means that it translates up. So that's what it does. You can graph this without knowing all that information. You just plug numbers in for x and it spits out a y. So if you put 1 in here, ln of 1 times 1/2, subtract that from 3, you get your y value. You don't have to do anything, but that is why it does what it does. Okay? When you get to c, let's see, what does c look like? F of x equals ln of x minus 1. Oops, I'm sorry, those aren't these need to be absolute value signs. Okay, so what that means when we put in that absolute value sign is it has an effect on the reflecting. Okay, and we're not going to get into that, but what it basically does is it reflects the negative outputs across the x-axis. So you end up with a weird graph that looks like, and it starts to turn, but it can't cross that because it puts us in negative bounds because it's the absolute value, and the absolute value gives me a positive y, and so we hit the line and then we bounce back up. So I'm not going to get into all that, but that's basically what happens there. And I don't think I have any homework problems with the absolute value sign, so I think you're okay with all of that. And the applications of these, if I remember right, pretty much they're just going to give you formulas. And you're going to plug numbers in for formulas. So, for example, look at number 12, or example 12. They give you the formula, WP equals 0.37. So they give you that formula. So you don't have to understand what that is, you just have to know what numbers to plug in. So for example, A, the population of Hartford, Connecticut is 124,848. Okay, that's P. So W, instead of P, we're going to put 124,848 equals 0.37 ln of 124,848 plus 0.05. Okay, so we just plug those numbers in. And this formula is the walking speed, okay, based on population. So you get an answer of, should get an answer of 1.8-ish for Hartford. And then when you go to San Antonio, Texas, you'll notice that the population is higher, and the average walking speed, when you put 1,236,249 in here for P, here and here, you get a walking speed of 2.7. So it looks like the more people there are, the faster they walk, maybe so they don't get run over. Alright, in example 13, there's one with earthquakes, so you're just basically just plugging numbers in there. So that's it for lesson 4.3.